Mensuration. Area of a quadrilateral. You know how to find the area of a few quadrilaterals such as squares, rectangles, and trapeziums. Now let us learn how to find the area of a general quadrilateral. A general quadrilateral can be split into two triangles by drawing one of its diagonals. This is known as a triangulation. Let us consider the quadrilateral ABCD. From the figure, area of the quadrilateral ABCD is equal to the sum of the areas of triangle ABC and the triangle ADC. Now, area of the triangle ABC is equal to half the product of AC and H1, and area of triangle ADC is equal to half the product of AC and H2. On simplifying, we see that the area of the quadrilateral is half the product of the length of the diagonal and sum of the lengths of the perpendiculars drawn from the remaining vertices to the diagonal. Let us solve a problem now. Find the area of the quadrilateral PQRS shown in the figure. Given PR is equal to 8 centimeters, SL is equal to 3 centimeters, and QM is equal to 4.5 centimeters. We know the formula to find the area of a quadrilateral. The area of the quadrilateral is half the product of the length of the diagonal and the sum of the perpendiculars drawn on the diagonal from the opposite vertices. Let us now substitute the given values. Therefore, the area of the quadrilateral PQRS is 30 centimeters square. In quadrilateral ABCD, the lengths of the perpendicular segments AL and CM are given as 10 and 15 units respectively. If the area of the quadrilateral is given, find the length of the diagonal BD. We know that the area of the quadrilateral is half the product of the length of the diagonal and the sum of the perpendiculars drawn on the diagonal from opposite vertices. So we put in the given values. On simplification, we get the length of the diagonal BD. Thus, the length of BD is equal to 30 units. Rhombus is a special type of quadrilateral. Recall that a rhombus is a quadrilateral whose diagonals are perpendicular bisectors. Now, let's find the area of a rhombus using the triangulation method. ABCD is a rhombus. Therefore, its diagonals are perpendicular bisectors of each other. Here, the area of the rhombus ABCD is equal to the sum of the area of triangle ACD and area of triangle ABC. By simplifying this, we get the area of a rhombus as half the product of its diagonals. Find the area of the rhombus whose sides are of length 9 centimeters and 14 centimeters. Area of the rhombus is equal to half into product of the diagonals. Let us substitute the values to find the area. Thus, the area of the given rhombus is 63 centimeters square. Let us take another example. Find the area of a rhombus ABCD. Each side measures 13 units, and one of the diagonals, AC, measures 24 units. The length of one of the diagonals, that is AC, is given. We know that the diagonals AC and BD of rhombus ABCD bisect each other at right angles at point O. Hence, the lengths of segments AO and CO are equal and each segment is 12 units. We now need to find the length of the other diagonal, BD. Observe that the length of diagonal BD is the sum of the lengths of segments BO and OD. To find the length of segment BO, we consider the right angle triangle ABO and apply the Pythagoras property. Thus we find the length of segment BO. As the diagonals of a rhombus bisect each other, the lengths of segments BO and OD are equal. Therefore, the length of diagonal BD is twice the length of BO. Now we can use the formula half times the product of the diagonals AC and BD to find the area of rhombus ABCD. We then substitute the values of the diagonals in the formula and then simplify to find the area of rhombus ABCD. Therefore, the area of rhombus ABCD is 120 square units. Let us summarize what we have learned. Area of a general quadrilateral is equal to half into length of the diagonal into the sum of the perpendiculars drawn from the remaining vertices to the diagonal. Area of a rhombus is equal to half into product of the diagonals.